Hello and welcome back. This is a new section in geometry, and this is section 3 of Unit 8, and this is a section called the angle measures polygons. Okay, so we're going to identify and describe polygons, and we're going to apply the polygon interior sum theorem, angle sum theorem, to solve problems, and we're going to do the same thing for the exterior angle sum theorem. Okay, so let's first talk about what a polygon is. A polygon are closed figures formed with 3 or more line segments. So it's a shape with 3 or more sides to it. Okay, so I'm going to write that down here. So it is a shape with 3 or more sides. Okay, I'm sorry, not sides, sides. Sides. Okay. And so what we have here, okay, 3 or more line segments such that each segment intersects exactly 2 other segments, one at each endpoint, and no segments have a common endpoint, are collinear. Okay, we have convex polygons and we have concave polygons. So convex polygons are your typical polygon that you see. These both are convex polygons here. Okay, but a concave polygon is something where you have a indentation within that, that's your cave. Okay, so an indentation in that polygon. Okay, typically we'll be dealing with convex polygons, but if we have a concave, it's something that has a cave in it. Okay, an n-gon is a polygon with n sides. Okay, so we don't know. Okay, so we don't know how many sides. So don't know the number of sides. The number of sides. Okay, so now the other thing we need to deal with is talking about the names of polygons and the types of polygons that we have. Okay, and we've got, and they have names. Typically we've been dealing with triangles with 3 sides and quadrilaterals with 4 sides. Okay, we've done a hefty amount of work on those. But we have, sides 5 through 10 that have names. So a 5-sided figure is a pentagon. A 6-sided figure is a hexagon, 7-sided is a heptagon, octagon is 8 sides, nonagon, decagon. So when they say that you have this type of figure, you need to use this table and remember how many sides you have, because that will help us figure out and answer questions, knowing how many sides are in a polygon. Okay, so what we know about the sum of interior angles in a polygon is that we have this little formula here. Okay, we can add up any number of angle measures using this formula where n is the number of sides of the polygon. So that's important. Okay, n is the number of sides. Okay, so it says, what is the sum of the measures of the interior angles of a pentagon? Okay, and so, we have this pentagon here. All right, and, we know it's a pentagon. Okay, so it has 5 sides. All right, so a pentagon has 5 sides, meaning that n is equal to 5. Okay, so if I wanted to find the sum of the measures of that angle, okay, I simply plug it into my formula here. So my sum is equal to 180 times 5 minus 2. Okay, and so I'm going to do what's inside the parentheses first. I'm going to do 5 minus 2, so I get 180 times 3. And if I do 180 times 3, I want to say that that's 540. Okay, it sure is. So the sum of all those angles is 540 degrees. Okay, and that's just with a pentagon. Okay, and that's going to be true for all pentagons. So what you could say here, if you took angle M plus angle N plus angle O plus angle P plus angle L, okay, if you add all those angles up, you're going to get a total of 540 degrees. And that's what we're doing. Okay, we're just adding up the angles to a certain amount. Okay, so let's apply this use the interior angle sum theorem to answer this question. So over here, it wants us to find the measure of angle K. So figure out this angle here. I'm going to put an X there. Okay, and let's just think about this for a second. I know I've got, let's see how many sides we got. We got 1, 2, 3, 4, 5, 6. So this is a hexagon. Okay, I'm going to write that up here, that this is a hexagon. Okay, meaning it has 6 sides. Okay, and if it has 6 sides, that means that n is equal to 6. Okay, so we're going to use that formula, which is 180 times n minus 2. Okay, we know that n is equal to 6, so I'm going to plug that in. So I've got 180 times 6 minus 2. Okay, so I'm going to do 180 times, what is that, 4? Okay, 180 times 4 is going to be 720. Okay, so this is the total number of degrees. Now, we're not done yet, okay? But what I want to do, because I have that total number of degrees, I'm going to add all these numbers up and solve for x and figure out what that is. Because I have all the other angle measures, and I can figure out what x is. All right, so let's do that. Let's do, okay, let me do 106 plus 115, add them all up, plus 154, okay, and then plus 90, plus 107, okay, plus x, and that's going to equal 720 degrees total, okay? So let's combine our like terms. Let's add all these numbers up. I'm going to use a calculator. So if I've got 106 plus 115 plus 154 plus 90 plus 107, then that's going to give me a total of 572 plus x is equal to then 720 degrees. Okay, I'm going to subtract off 572 minus 572, and so we get that x is equal to 720 minus 572, and that's going to give me that x is equal to 148 degrees, okay? So our answer then, okay, if we find out what x is, we know that angle K is equal to 148 degrees, okay? And that's what we're looking for, all right? So we can use that as well. All right, the other thing, regular polygons, talking about regular polygons. Now, a regular polygon is something where both equilateral and equiangular. So what that means, like if I had a regular polygon, okay, and like a regular pentagon here, I know that all my sides are congruent, okay, Andrea, and that all of my angles are also congruent, okay, in a regular polygon, okay. So if I wanted to figure out what one of these was, okay, what any of these angles are, okay, I know I have 5 sides, so here's what I could do. Okay, if I had 5 sides, so in a pentagon, okay, n is equal to 5, all right, and I'd plug it into my formula, 180 times 5 minus 2, okay, so that's 180 times 3, which gives me 540 degrees, okay, and if I have 5 sides, okay, this is 5 sides here, okay, 5 sides. That means that I also have 5 angles, okay? And if all my angles are congruent, okay, to figure out what one of them is, if I know I have a regular polygon here, I'm going to take 540 and divide that number by 5. So if I take 540 and divide it by 5, that's going to give me a measure of 108 degrees, okay? And so what that means is that all these angles here are 108 degrees. 108 degrees. 108 degrees. 108 degrees. 108 degrees. Next page! Okay, so we still need to apply that polygon interior angle sum theorem. If we know an interior angle of a regular polygon has a measure of 140 degrees, what type of polygon is it? So basically what we're trying to do is we're trying to solve for n, okay? So this, we are solving for n, okay? Now what I know is that we have a regular polygon. Each of those angles measure was 140 degrees. Now remember what I did. Okay, I took my formula, which was 180 times n minus 2. I figured out the total number of degrees depending on what my n value was. And then I divided that by the number of sides to give me what each of those angles was. And then we can set that equal to the angle measure that each of those angles are, which is 140, okay? And so at this point, what we can do is we can solve this for n. All right, now this is a little bit tricky, but we're solving this for n. So what I know is I have these two n's, okay? We have to get this first n out of our denominator, okay? And the way that I do that is I multiply both sides by n. Okay, so these n's divide out. You are then left with 180 times n minus 2, and that's equal to 140n. Okay, I'm going to do this problem up here. What I'm going to do first is I'm going to distribute my 180. So I'm going to get 180n, okay, minus 180 times negative 2, which is 360, and this is equal to 140n. Now, if I subtract by 180n, minus 180n, then we end up getting negative 360 is equal to negative 40n. Now if I divide everything by negative 40, divide by negative 40, then we end up getting that n is equal to, all right, let's do 360 divided by 40. It's going to give me 9. N is equal to 9. So we have a nonagon, okay? So a nonagon. All right, and that's the side that we have. All right, and so, if you think about it, it's the same thing that we did on the previous page. Okay, except for I'm not solving to trying to find what one of those angle measures are. I'm trying to figure out what type of figure it is if all the angles in a polygon are 140 degrees. I can use this formula here, okay? All right, the next thing that we have is what we call an exterior angle of a polygon. So an exterior angle of a polygon is an angle formed by a side of a polygon and an extension of an adjacent side. So here's what I've got, okay, and this is a little bit tricky. If I were to extend these lines out in this direction, all of these angles here are what we call exterior angles, okay? And that's what that means. Okay, now we also have an interesting theorem about that. What we know is that if we take all the angles, if exterior angles of any polygon that is convex, we add them up, we will always get 360 degrees every single time. Okay, so what I know about this is that if I were to take angle in a regular polygon, I want to know what would one of these be, okay? So I'm just going to call these angles x, okay? And if I have a regular polygon, then all of these exterior angles are going to be congruent, okay? So with that, I know that if I add all those up, I'm going to have 5 x's that I added up. All of those are going to equal 360 degrees. Okay, and if I take 360 degrees and I divide that by 5, okay, that's going to give me that x is equal to 72 degrees. Okay, so what is the measure of each of those? They are each 72 degrees. Okay, all of them add up to 360 if it's an exterior angle. Okay, so now what about something like this? All right, where you've got a problem like this where you have some of these, but you're trying to figure out one of the angles, okay? So what is the unknown angle measure, and then what is the value of x? Okay, so what I'm going to do is I'm going to add all of these numbers up, and I'm going to set it equal to 360. So I'm going to do this. I'm going to do 90 plus 72. Well, let's do this. Let's not do 90. Let's start off with x plus 7. First, and then plus 72, plus 90, plus 82, plus 96. Add them all up, we're going to get 360 degrees. Okay, so let me combine my like terms. Let me add the 7, the 72, the 90, the 82, and the 96 together. Okay, so I'm going to do 7 plus 72 plus 90 plus 82 plus 96. Okay, and that's going to give me that x plus 347, when I add all those numbers up, is going to give me 360. Okay, so then if I subtract off 347 from everything, then that's going to give me that x is equal to, so 360 minus 347, it's going to give that x is equal to 13. Okay, so we figured out the value of x, but we also need to plug this back in to find what this angle measure is. So if I find that angle measure, it's going to be 13 plus 7, which is a 20-degree angle. Okay, so guys, pretty easy as long as you understand, the vocab and, what exactly it is that we're doing. This really isn't too bad of a section. So I hope you enjoyed the video, and we'll see you soon. Thank you. Bye-bye.